Hey everyone, today I want to talk about agent specifications engineering. That is the art of importing engineering rigor into production AI systems. This is part of the AI product craft series. So, there are two architectural patterns in AI systems today. The first pattern is we build them with system prompts. They work reasonably well. That means you're giving natural language prompts and the LLMs and the AI features that use your LLMs respond with answers. They work well for the most part. But what if your customers want and insist and require very, very reliable, specific things? For example, when you look at a particular number in an Excel sheet, this is what the number means. You should always interpret it this way and so on. So that's like if somebody, if a customer asks for not just for pasta, but your customer is asking for, butternut squash ravioli with specific, cheese on top and specific cooking times and specific, specific recipes and so on. How do you ensure that that's exactly what your AI production application will produce every time consistently? And that is why you need agent specifications. These are formal definitions that govern behavior, that use tools and then validate the results, so that you can guarantee to your customers that when we do some work for you, we will not let our feature hallucinate. We will produce exactly what you need. It could be a presentation, it could be an analysis, a report, a calculation. No matter what it is, if you want predictability and yeah, the exact results every time, so you need specifications. So what is specifications engineering? It's the practice of defining explicit enforceable system contracts that govern how an AI system behaves. It shifts the focus from oh, please do this, and I'm hoping that I will get a right answer most of the time, to no, the system must guarantee that this will happen all the time, and we can do it. We do it. I do it in my company. um, so that's what this specification engineering is. um, so all right, that's again, that's all conceptual and good. So what exactly is an agent specification? What exactly does it look like, and what does it contain? It contains all the standard things a normal prompt contains. A normal system prompt contains. It'll have an objective. You can say, who you are, and then it'll have a schema. For example, you can say this is how the input will be given to you, and this is how the output will be given to you. Um, and it will have the ability to call a specific set of tools. You can control which tool it can call. And in this case, what I've done is the tool is also part of the spec. The spec has the system prompt as well as the tool, which is in this case a small Python program that counts the number of words in a transcript. And then finally, there is a validation, and the validation code is also on the right side. After the LLM returns a result, this validation code is run to verify if the result was as reliable as it should be. So that's the structure of it. This is the exact same script. We are actually going to see a demo of this in a minute. Um, so, what is the structural difference between prompt driven AI features and specification driven prompt driven agents and specification driven AI agents? The source of the behavior is natural language. You prompt for prompts, you just write in natural language, whereas in specification driven, you write a formal contract. Contract means a very specific deterministic piece of code, as we saw in the previous slide, Python code that we know for sure will always perform exactly as we want it to perform. Validation, usually prompt driven, you usually validate it using, it's implicit validation. You know that it'll work, or you'll just glance at it, or you'll write some LLM as a judge um, validations, and then for the most part it'll work, but you cannot guarantee 100% it'll work. Whereas in explicit rule based agents, at least that particular part will work uh, exactly as we want it all the time. And then, what is, from a readiness point of view, prompt driven agents are good for demos, good for POCs, and good for maybe some production applications where some amount of error is okay, is acceptable. But if you want high enterprise grade AI applications where your customers insist that it must be right 100% of the time, then you specifications driven agents are the best route. So, why should product managers care? Uh, by now, you probably know that if you want to build AI, enterprise grade AI applications, then they need to be reliable. You should be able to control risk and variability. It should be testable. You should be able to prove to your customers that it'll work the same way every time. And then finally, once you write agent specs, you can take the same spec and repeat it in multiple places without the behavior changing. So those are the advantages. So now let's go back and look at a very simplistic example of what how an agent spec will work compared to a prompt. Um, so, for example, if I want to write an agent that counts the number of words in a transcript, I can provide an input. Say, let's say I'm going to say this is a this is a sentence, and that's my input, and then I can say um, instead of just say count the number of words in the sentence, that would be the prompt driven approach. I want to be very, very specific. So I am going to give this complete specification. So the system prompt is on the top, and I'm pointing out that it must call the Python tool to execute to calculate the number of words in this transcript. And then I've also added a validation code at the end of it. So in production grade systems, this will be done in a much more sophisticated manner using tools and interfaces, and your engineers will teach you how to do that. But for the sake of the demo, I'm just going to paste it right here. This is like I've written the I've 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 pasted the entire spec here, and the input is here, and I'm going to run this. So ideally, it should say there are 4 words, and the validation code ran, and it said validation is true. Okay, so that's obviously a very, very oversimplified agent spec. In normal situations, the agent specs could be very, very long, and the agent specs, although the early versions of agent specs can be written by product managers, agent specifications are usually reviewed by engineers who are trained in software engineering, and they will review it, and then they will deploy it to production. You can version control it, so that it'll be treated exactly like software code. Now, um, for product managers, if you want to build demos or prototypes or early versions to test things out, and if you want to write an agent spec, let's say I want to write a Python code that will count the number of transcripts in count the number of words in a transcript. So do I need to rely on engineers even for prototyping? No, you don't have to. There is a way of doing it even if you don't program. Like, I don't program in Python, but I wrote this agent script. This is how I did it. You go to simply your favorite large language model and say write a Python um, script to count the words in a transcript. In a transcript, and you can also say write the validation code as well. Well, and if you do that, and I'll also say write system prompt, combine these into unified agent specification. So I'm using again I'm using the large language model itself to write the specification here. Um, so most likely it should write the specification and give it to you in a very clear. It's giving it to you in a YAML format, which is a very commonly understood format. So it's giving you a more elaborate specification. This is agent spec, name, transcript, word count, agent, purpose, compute an exact word count for a provided transcript and validate. And then the system prompt is here, and it says you must call the tool, you must call the Python tool word counts, you must call the Python tool validate, and then here is the Python tool that is described. This is the word. This is to count the words, and this is to validate it, and so on. So this may not be production ready, but you can use this for prototyping, and once you're happy with the way it works, your engineers will take it to understand what you want, much like a product definition document, and they will then make it production ready. Obviously they are more skilled than you are in this craft. This is how we are building reliable production grade AI applications for our enterprise customers who pay us millions of dollars. And this is how every production grade AI application will be built, I believe, um, going forward. I hope that helps.